We're being asked to evaluate this line integral around this contour or curve, but we're not being asked to just evaluate it. We're being asked to evaluate it using Green's theorem. That means we're not supposed to start finding parametric equations for each side. We're supposed to remember that the conclusion of Green's theorem says that this should be a double integral. We'll figure out the limits of integration in a second. Remembering that this is f2, this is f1. It's going to be the partial of f2 with respect to x minus the partial of f1 with respect to y. Like this. I'm just going to put dA for the moment and evaluate that integral instead. Well, let's put it over here. We'll worry about the limits of integration in a second. What we have is 2x plus 2y. I'm going to go dy first. I just think the limits of integration will be easier to set up that way. Remember how we set up limits of integration? We draw a slice. Remember that's x0. That's xx. And the y coordinates there give us the limits of integration for our integral. And then to get dx, we just have to say how far left can we chop. We chop as far left as 0. We chop as far left as 1. And we get to do this integral and see what we can get from it. So here we go. I'm just going to take the antiderivative with respect to x. So that's going to be x squared plus 2xy, like that. And we're supposed to go from 0 to x, dx. When we plug in the 0, we just get 0. So the only thing we really have to worry about is what happens when we plug in x. What we're going to get is x squared plus 2x squared, that's 3x squared. Like this. This is a nice, easy integral to do. It's just going to be x cubed from 0 to 1, and we get 1. Ta-da!